Alright, notes 3.8, analyzing polygons with coordinates. So we've talked about slope last year in algebra. Slope, it's the measure of steepness. Alright, the slope of a line tells you how steeply a line is increasing or decreasing. So the slope of a non-vertical line that contains the points x1, y1, and x2, y2 is equal to the ratio. This is y2 minus y1 over x2 minus x1. Or we could do y1 minus y2 over x1 minus x2. So notice how the y2's come first, y2 and x2, or y1 and x1. As long as they both are the same, that is your slope formula. Now finding slope, so we can graphically find it or we can look at it algebraically. Graphically, it goes over 6 and up 3, so it's rise over run. So the slope here is 3 over 6. Algebraically, we use our formula y2 minus y1 over x2 minus x1. So we have, this is x1, y1, x2, y2, so we have 6 minus 3 over 8 minus 2. 6 minus 3 is 3, 8 minus 2 is 6, and 3 over 6 is the slope of 1/2. And then the same thing over here, so we have the slope of 1/2. So we have the same slopes, well, graphically and algebraically. So if we want to find the slope with endpoints 5, -3, and 2, 3, we simply use our formula y2 minus y1 over x2 minus x1. So we have 3 minus -3 over 2 minus 5. This is 6 over -3, which is -2. Has a slope of -2. Now we have two things we're going to talk about: parallel lines and perpendicular lines. Well, if we recall from algebra, the equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. Well, in a figure, the equation of one line is y equals 1.5x plus 2. So the slope is 1.5, or 3 over 2, and the y-intercept is 2. In the second line, it's y equals 1.5x minus 3, where the slope is 1.5, or 3 over 2, and the y-intercept this time is -3. Now, both lines have the same slope. They have a slope of 1.5, and they're parallel. So you should recall that from last year in algebra, that lines that have the same slope, they're parallel and they will never touch. So our parallel lines theorem: in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. So parallel lines have the same slope, and any two vertical lines are parallel. Now, vertical lines, they don't have, their slope is undefined, so that's why it's any non-vertical lines. So any two lines that have the same slope are parallel lines. So if we look at the next part, this is our perpendicular lines. What special relations? Alright, so we can plot these points -2, 4, and 1, -2, connect them, and then we can plot -3, 1, 3, and 4. We can connect them. If you need more time, you can always pause this. Now what we notice here is that when these intersect, they form right angles. And we plot these points -2, 2, 4, -2, and -1, -3, 3, 3. Once again, when we intersect these, forms right angles. How can we tell that these lines are perpendicular? They form 90-degree angles, and we can also take a look at their slope. So they form 90-degree angles, and if we look at their slopes, well, look at the slope of this first line. So we have -2 minus 4 over 1 plus 2, because that's negative 2. So this is going to be negative 6 over 3, which is negative 2. And we look at the slope of this, so we have 4 minus 1 over 3 minus negative 3, which is 3 over 6, which is 1/2. So now we have this relationship between, we have 1/2 and we have negative 2 over 1. And if we look at this one, the slope here, negative 2 minus 2 over 4 minus negative 2 gives me a slope of negative 4 over 6, which is negative 2 over 3. 3 minus negative 3 over 3 minus negative 1 is 6 over 4, which is simplified to 3 over 2. Now, so we have a negative 2 over 1 and 1/2. Now we can compare these two values. Here, these are the slopes, and these slopes are negative 2 over 3 and 3 over 2. If we want to compare them, alright, in a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is negative 1. So that means if you multiply this by negative 1, the slope's negative 1. Any vertical line is perpendicular to any horizontal line. So when we multiply these together, we're going to get negative 1. So negative 2 times 1, 1 times negative 2, negative 2 over 2, which will give us negative 1. The other way that we can think about is that this is the negative reciprocal. So we can flip this. So 3 over 2, and from negative to positive, it's the negative reciprocal. So if it's the slopes are negative reciprocals, they are perpendicular. Or if you multiply them together, it gives you negative 1. So if we look at example 3 here, we can draw this quadrilateral and find the slope. So Q is 1, 4, 1, 4. U is 7, 8. 7, 8 is U. A is 9, 5. There's A. And D is 3, 1. D, so we can connect this Q. Now we can try, you can look at it and figure out what shape it is, but we can use the slopes to determine what type of quadrilateral this is. So slope of Q and U. So here's Q and U. So we have 8 minus 4 over 7 minus 1. That's 4 over 6, which is 2/3. Slope of DA. Well, here's D and A. So 1 minus 5 over 3 minus 9. That's negative 4. That's negative 6. Two negatives give you a positive. Slopes of 2/3. Slopes of Q to D. So Q to D. So I have 1 minus 4 over 3 minus 1. 1 minus 4 is 3. 3 minus negative 3. 3 minus 1 is 2. And slope of U and A. So this is 5 minus 8. And 9 minus 7. Negative 3 over 2. So what type of quadrilateral do we have? Well, what we know is that we have two sets of parallel lines. Alright, QU is parallel to DA, and QD is parallel to UA. They have the same slopes. Alright, two sets of parallel lines. Alright, they have the same slopes. They have same slopes. So we have parallel lines, and then what else we notice is that these are opposite reciprocals. Alright, so you multiply them together to give you negative 1. Opposite reciprocals. Alright, so you flip this first fraction. It's 3 over 2, you make it negative. So we know that QD or QU is perpendicular to QD, and DA is perpendicular to UA because they have opposite reciprocal slopes. Slopes are opposite reciprocals. So now we have two sets of perpendicular lines. So we have right angles, and we have two sets of parallel sides. So this is a rectangle. We have parallel lines and we have perpendicular lines. So perpendicular angles and parallel lines. And then our mid segment in the coordinate plane, the midpoint of the segment with endpoints x1, y1 and x2, y2 has a following coordinates x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Now this midpoint, it's just the average of the coordinates. So we can draw this triangle, 2, 6. Here's 2, 6, 0, 0, 4, 0. So here's our triangle. We have A, B, and C. And now we can find the averages of them. So the midpoint of AB, we have 6 plus 0 divided by 2. Actually, that's the y value. And we have 2 plus 0 divided by 2. So 2 plus 0, this is 1 and 3. So the midpoint of AB should be 1, 3. The midpoint of AC, 2 plus 4. 2 plus 4 divided by 2. 6 plus 0 divided by 2. So this is going to be 3, 3. 3, 3. And then the midpoint of BC, so of AC of BC, we have 0 plus 0 divided by 2, or 0 plus 4 divided by 2, and 0 plus 0 divided by 2. So this is 2, 0. And that is the midpoint of each one of these. And that is, we will pick the next part up tomorrow.